Hello everyone, welcome to today's lecture on the overview of building envelope and insulations. I am thrilled to guide you through this exploitation of energy efficient buildings. In this preview lecture module, we have already learned about introduction to energy efficiency in buildings, design consideration for different climates, energy efficiency strategies for new buildings and existing buildings, energy retrofit of existing buildings, energy efficient HVAC system. So, in this lecture we will start a new module on building envelope and insulation in energy efficient building. In this module we will learn about understanding the building envelope, components of building envelope, role of building envelope in energy efficiency, factors affecting building envelope performance. The outline of this lecture will be as follows: overview of understanding the building envelope, what is building envelope, components of building envelope, role of building envelope in energy efficiency, factors affecting building envelope performance, overview of component of building envelope, impact of design materials and construction practices, benefit including envelope, factors affecting building envelope performance, material properties and design characteristics, insulation, air and moisture barriers and maintenance, energy efficiency, indoor comfort and the overall durability of building, and climate design and building orientation. So, let us begin with our discussion critical concept of the building envelope. We will explore its various components, their functionalities and the role they play in creating a comfortable, energy efficient and sustainable built environment. By understanding the building envelope, we can design and construct structure that are not only aesthetically pleasing, but also contribute to a healthier planet. This is building envelope and its components. In this presentation, we will discuss building envelope components as a protective shell that shield the building occupant from the element. It is a complex system with various components working together to maintain a comfortable and healthy indoor environment. A well designed envelope optimizes energy use, minimizes environmental impact and contribute to the overall durability of building. The building envelope plays a multifaceted role in ensures occupants comfort by regulating temperature and moisture. It minimizes energy use for climate control, leading to cost saving and environmental benefits. Additionally, the building envelope contribute to a peaceful indoor environment by controlling noise level. Finally, it safeguards the building from external element, promoting long term durability and safety. The primary component of a building envelope includes wall, roof, window and door, foundation, air and vapor barriers, sealants and flashings. Its main function is maintain indoor temperature by reducing heat loss in winter and heat gain in summer, preventing water infiltration and managing humidity level to protect the building structure and indoor air quality, minimizing air leakage to enhance energy efficiency and occupant comfort, providing the necessary support to withstand environmental loads such as wind, snow and seismic activity, contributing to visual appearance and design of the building. We can discuss function of building envelope. In this presentation, we will delve into building an envelope that keeps you cool in summer and warm in winter. This is the power of environmental control. The envelope acts as a thermal barrier, regulating heat flow and preventing extreme temperature inside. Additionally, it manages moisture to prevent condensation and mold, which this led to health problems and property damage. While rising energy cost, a growing focus on sustainability, building envelope plays a critical role in energy efficiency by minimizing heat gain or loss. The envelope reduces the demand for heating and cooling system, optimizes insulation within the envelope, further enhance energy performance, leading to cost saving and a more environment friendly building. Here are primary function of the building envelope are thermal regulation, moisture control, air control, structural support, acoustics, insulation, fire protection, aesthetic appeal, security and energy efficiency and sustainability. The building envelope is a critical component that ensures the comfort, safety, efficiency and durability of a building. Its design and material must be carefully selected and integrated to fulfill these diverse functions effectively. In this presentation, we will delve into the foundation and walls, the critical cornerstones of a high performing building envelope. The building envelope is the physical separator between a building conditions and unconditioned environment. Its performance significantly impact factors like energy use, thermal comfort, durability and acoustics. By understanding the role of foundation and wall and how they contribute to the envelope overall effectiveness, we can design, construct buildings that are both functional and sustainable. There are several key performance considerations for foundations. First and foremost is structural capacity. The foundation need to be robust enough to handle the building's weight and any additional load it may encounter. Another crucial aspect is moisture control. As mentioned earlier, foundations are exposed to moisture from the ground. To prevent water from entering the building, proper waterproofing and drainage system are essential. These can include waterproofing membrane on foundation wall, drainage mats that channel water away from the foundation and weep holes that allow any trapped water to escape. Finally, in cold climate, insulating the foundation below the frost line can significantly improve thermal performance by minimizing heat loss from the building's interior. In this presentation, we will delve into two critical components of building envelope, the foundation and wall. These elements from the base structure of the building, playing a vital role in its overall stability, durability and energy efficiency. By understanding their function and materials, we can design and construct buildings that are strong, secure and comfortable for their occupants. Building wall are the vertical structure that defines the building perimeter and separates interior space. They play a critical role in structural support, weather protection and even aesthetics. A variety of material can be used for walls with its own advantages and disadvantages. Brick wall offers classic beauty, durability and thermal mass. Foundation in the lowest part of the building structure, which transfers the load of a building to the ground and provides stability. It consists of several key elements: footing, foundation wall, waterproofing, insulation. Wall are the vertical element of the building envelope that enclose and protect the interior space. They provide structural support, thermal insulation and a barrier against the element. It consists of exterior cladding, insulation, shielding and air and water barriers, framing and interior finish. Its key consideration is avoiding materials of construction methods that create path for heat transfer through the envelope, reducing insulation effectiveness, ensuring proper drainage, water barriers and ventilation to prevent mold and structural damage. That encloses and protect the interior spaces. They provide structural support, thermal insulation and a barrier against the element. It consists of exterior cladding, insulation, shielding, air and vapor barrier, framing and interior finish. Its key consideration is avoiding materials of construction methods that create path for heat transfer through the envelope, reducing insulation effectiveness, ensuring proper drainage, vapor barrier and ventilation to prevent mold and structural damage, implementing continuous air barrier to prevent uncontrolled air leakage, using materials and construction method that withstand environment stresses and require minimal maintenance. In this presentation, we will explore two critical components of building envelope, that is roof and window. The roof acts as a topmost shield protecting the building from the element. Window provides natural light, ventilation and by connecting to the outdoor. By understanding their function and consideration, we can design and construct buildings that are not only weatherproof but also light filled with energy efficiency. Just like wall insulation, proper roof insulation is crucial for energy efficiency. By reducing heat transfer through the roof, insulation help maintain comfortable indoor temperatures throughout the year. This translates to lower energy consumption for heating and cooling system. Function of windows: natural light which allow daylight into the building, reducing the need of artificial lighting and enhancing occupant comfort level and well-being. Ventilation that facilitates natural air exchange, improving air quality and comfort. Thermal insulation which improves the building energy efficiency by reducing heat loss in winter and heat gain in summer, especially when using advanced glazing and frame material. Sound insulation help to reduce external sound, contributing to a quieter indoor environment. Aesthetic appeal is enhances the visual appeal of the building, contributing to its architectural style and character. And last, security provides physical security through the robust design and locking mechanism, preventing unauthorized entry in the building. We are starting next slide, that is air and water barrier. In this presentation, we will delve into two critical building envelope component, that is air barrier and water barrier. So, these invisible layers play a vital role in protecting the building's interior from the element. Air barriers manages air infiltration, controlling draft and energy loss. Water barrier prevent water intrusion, safeguarding the building structure and promoting healthy indoor air quality. By understanding the function and type of these barrier, we can design and construct building that are comfortable, durable and energy efficient. Water barrier purpose is to prevent water infiltration and air barrier purpose is to prevent air leakages. Air barrier controls the unintentional movement of air into and out of a building. This helps maintain consistent indoor temperature and reduces energy consumptions. Enhance energy efficiency by minimizing air leakage. Air barriers improve the building thermal performance, reducing heating and cooling loads, improve indoor air quality, controlling airflow, helps prevent contaminants and pollutants from entering the building. Enhancing indoor air quality, water barrier blocks water from the entering the building envelope, protecting structural component from moisture damage, manages moisture. Proper moisture management help prevent issue like mold, mildew and rot which can compromise structural integrity and indoor air quality. Improve durability by preventing water infiltration. These barrier extends the lifespan of building material and water in a major enemy of building. Water intrusion can lead to structural damage, mold growth and unhealthy indoor air quality. Ensuring that air and water barrier are continuous and properly sealed in all joint of the building. And penetrations is useful for their effectiveness. Using materials that are compatible with each other and with the building's structural component prevents issue like chemical reactions or adhesion failure. Selecting barrier that are appropriate for the local climate and building type ensures optimal performance and durability. Proper installation is crucial. Even the best material can fall if not installed collectively, so leading to air and water leaks. Now, we will discuss about vapor barrier and insulation. So, in this slide we will explore two critical building components that works hand in hand, vapor barrier and insulation. Imagine your building envelope as a protective system for your home. Insulation act like a warm blanket, trapping heat in the winter and keeping a cool air in summer. A vapor barrier on the other hand is like a strategically placed shield that controls moisture movement within the envelope. By understanding the function and type of these elements, we can design and construct buildings that are comfortable, energy efficiency and healthier. This helps to prevent condensation from forming within the wall capacity, which can lead to mold growth and structural damage. Additionally, vapor barrier safeguards the insulation effectiveness. Wet insulation loses its ability to trap heat, so keeping it dry is crucial for optimal thermal performance. Now, we are starting new slide, that is material consideration for efficient building envelope. In this presentation, we will explore the building envelope protective shell of a building, separating the conditions in interior from the unconditioned exterior. The material chosen for the envelope plays a vital role in a building overall performance. In this presentation, we will explore key consideration for selecting efficient building envelope materials. By making informed choices, we can design and construct building that are comfortable, energy saving and environmental friendly. Thermal performance refers to a building ability to maintain comfortable indoor temperature while minimizing energy use. The selection of building envelope material significantly impact this aspect. General consideration that are climate appropriateness, selected materials suitable for local climate condition, example high humidity, extreme temperature, wind loads. So, in building, as per building codes and standards that ensures compliances with local building codes, energy standards and fire safety regulations. Sustainability consider the environmental impact of material including embodied energy, recyclability and potential for sustainable resourcing. Cost balance initial material cost with long term benefits such as energy saving, durability and maintenance requirement. Now, we will discuss in next slide about design consideration for efficient building envelope. In this presentation, we will explore efficient building envelope in understanding the local climate. A building designed for a hot desert climate would not perform well in cold mountain region. Climate responsive design principle helps us to create envelope that are optimized for the specific environment. In hot and dry climates, maximizing shading, utilizing natural ventilation strategies and choosing light colored reflective material for the envelope can significantly reduces cooling loads. Temperature climate requires a balance between allowing solar heat gain in summer for passive heating and in providing shading to prevent excessive heat gain in summer. Optimizing natural daylighting and ventilation are also important consideration for cold and snowy climate. Prioritizing high insulating walls, minimizing thermal brightening and points where heat can escape and designing the roof to handle snow load are crucial aspect of building envelope design. Now, in next slide we will discuss about the role of building envelope in energy efficiency. So, in this slide the building envelope plays a critical role in determining a building energy efficiency. A well designed envelope act as a thermal barrier, minimizing heat transfer in both summer and winter. In the winter, this translates to less energy needed for heating the building. Similarly, during the summer, a well designed envelope reduces heat gain from the sun, lowering the need for air conditioning. On the other hand, a properly designed envelope with air leaks, inadequate insulation or inefficient windows can significantly increase energy consumption. Uncontrolled air infiltration and heat transfer through the envelope forces heating and cooling system to work harder, leading to higher energy bills and a large environment footprint. Finally, designing the building envelope to respond to the local climate is essential. Strategies like maximizing shading in the hot climate or optimizing solar heat gain in cold climates can significantly improve energy efficiency. Now, we will discuss in next slide key design consideration for an efficient energy building envelope. The first step towards an efficient building envelope is understanding the local climate. A building designed for a hot desert climate would not perform well in a cold mountain region. Climate responsive design principles help us create envelopes that are optimized for the specific environment. In hot and dry climate, maximizing shading, utilized natural ventilation strategies and choosing light colored reflective materials for the envelope can significantly reduce cooling loads. Temperature climate requires a balance between allowing solar heat gain in winter and passive heating and providing shading to prevent excessive heat gain in summer. Optimizing natural daylighting and ventilation are also important considerations. For cold and snowy climate, prioritizing high insulation values, minimizing thermal building points where heat can escape, and design the roof to handle snow loads are crucial aspect of building envelope design. Now, we will discuss in next slide the factors affecting envelope performance. In this presentation, we will explore building envelope plays a central role in determining a building energy efficiency. A well designed envelope acts as a thermal barrier, minimizing heat transfer in both summer and winter. In the winter, this translates to less energy needed for heating the building. Similarly, during a summer, a well designed envelope reducing heat gain from the sun, lowering the need of air conditions. The climate is a fundamental factor influencing building envelope design. In hot and dry climates, the envelope should be designed to minimize heat gain. Strategies like maximizing shading, utilizing natural ventilation for cooling, and selecting light colored reflective materials for the exterior surfaces can significantly improve comfort and energy efficiency. Temperature climates require a balancing act. Allowing some solar heat gain in winter for passive heating is desirable, while controlling solar heat gain in summer is also important. Optimizing natural daylighting and ventilation are additional consideration. Cold and snowy climate necessitate a focus on high insulation values to minimize heat loss, minimizing thermal binding point to prevent heat escape, and also to determine the roof structure to handle snow loads. Now, we will discuss in next slide about building energy efficiency, occupant comfort and durability. In this presentation, we will explore strategies we can employ to achieve building efficiency. The building envelope, the protective shell separating the conditioned interior from the exterior plays a crucial role. A well designed envelope with high insulation value, proper air sealing to minimize air leaks, and strategically placed window are optimized. Natural light and solar heat gain depending on the climate can significantly reduce energy need for heating and cooling. Energy efficiency, building consumes less energy, reducing operational cost and environmental impact. Comfortable building provide a healthier and productive environment for occupant. Durable building requires less maintenance and have a long lifespan. This presentation will explore how we can achieve the ideal balance by considering key design and constructive principles. Now, in next slide we will discuss about wall assembly design in building envelope. In this presentation, we will explore different type of wall assembly, each with its own advantage and disadvantage. Framed wall are the most common type, offering flexibility and ease of consideration. They typically consist of a wooden frame with studs, insulation sandwiched between the studs shearing and the exterior side, and interior and exterior finishes. Masonry wall constructed from concrete block, bricks or stones offer high strength, fire resistance and durability. Insulated concrete form ICF wall are a relatively new technology that utilizes hollow concrete form filled with insulating material to create a strong energy efficient wall system, curtain wall and a non-structural wall typically made of glass and metal framing, using for aesthetics and light transmission in commercial building. Wall are a fundamental element of any building, providing structural support, defining interior spaces and separating the conditioned interior from unconditioned exterior. Wall assembly design involves selecting the right material and component to create a wall system that meet specific performance requirements. Now, we are coming in next slide, that is factors affecting envelope performance. So, in this presentation we will explore the various factors that influences the performance of building envelope. The building envelope is a physical separator between the conditions and unconditioned environment, and its performance significantly impact a building's energy use, thermal comfort, durability and acoustics. By understanding these factors, we can design and construct envelope that are both functional and sustainable. These key performance area are crucial for successful building envelope. All these factors during the design and construction process, we can create envelope that meet the need of the occupant and the environment. Each element of the building plays a role in overall performance. Wall and roof provides thermal resistance and weather protection. Window and doors allows for light and ventilation and access, but can also be significant source of heat gain or loss. The foundation provides structural support and helps to control moisture intrusion. The air barrier is essential for maintaining energy efficiency and indoor air quality. So, we are starting new slide, that is additional consideration for building envelope performance. In this presentation, we will explore key performance area that are crucial for a successful building envelope. By considering all of these factors during the design and construction process, we can create envelopes that meet the need of occupant, the environmental and future generations. Life cycle assessment is a relatively new consideration, but one that is becoming increasingly important. It allows us to assess the environmental impact of a building envelope throughout its entire life cycle, from material extraction and manufacturing to construction operation. Each element of a building envelope plays a role in its overall performance. Wall and roof provides thermal resistance and weather protection. Windows and door allow for light ventilation and access, but can also be a significant source of heat gain or loss. The foundation provides structural support and help to control moisture inclusion. The air barrier is essential for maintaining energy efficiency and indoor air quality. Fire barriers are crucial for life safety and must meet buildings code requirement. A well designed building envelope is essential for creating energy efficient, durable and comfortable building. By understanding the function and selecting appropriate materials for each components, buildings and designers can ensure that the building envelope performance effectively in maintaining heat, air, moisture, light and sound. This holistic approach lead to enhanced occupant comfort, reduced energy consumption and increased building longevity. Throughout careful planning and execution, the building envelope can significantly contribute to the overall sustainability and performance of the built environment. Understanding the building envelope involves comprehensive its components, function and material considerations. A well designed building envelope enhances energy efficiency, structural integrity, moisture control and overall occupant comfort. By selecting appropriate materials and ensuring proper insulations, the building envelope can significantly impact the performance and sustainability of any building. Thank you.